Okay, so we're now live on Facebook. I want to welcome everybody to this week's xEssentials class, which is on why megatrees fail. Stay tuned for after the call for a couple of announcements, as well as what we're going to be covering in the upcoming xEssentials presentations. And make sure if you have any questions during the presentation, you can place them in chat, or at the end of the presentation, you can raise your hand and Jonathan will call on you. And just a quick reminder to please make sure you're muted and that all the cameras are turned off. So, Jonathan, you've got the floor.
Thanks, Ed. Hopefully everybody can hear me and see the screen okay. If not, let me know. So thanks for having me back again. I did a couple of these presentations last year, and hopefully they were well received, at least received well enough that you guys didn't fall asleep completely and said, never invite this guy back again. So this time I'm here not to talk about something specifically xLights related, but why megatrees fail, and kind of offer a structural engineering perspective on that. Just a quick overview of what I'm going to be talking about, just an introduction as to what we're going to be going over, why we care if megatrees fall down, and then go into kind of the different elements that make up a megatree and where the weak points typically are from what I've seen. And then we'll ask some questions, and if we have time, we'll give answers to those questions. But some of the questions of how to do it perfectly, we may not be able to answer. There is no complete solution for making an absolutely perfect one, especially if you're on a budget. We're all kind of do-it-yourselfers, or most of us are anyway, and it's difficult to come up with an absolutely perfect solution that would be guaranteed not to fall down. We're just trying to minimize that. So just a little bit about me, just because I'm going to be talking about some structural concepts here. I am a structural engineer. I'm licensed in 3 different states. I've got 20 years of experience doing bridge design for the most part. I do some with other things such as sign poles, light poles, and that, because they're associated with transportation type structures. So I do a lot of those type of projects. I've got a background in this stuff. I've taught a few classes, just not a course, but a class for structural engineering, both at undergrad and graduate level, and done many presentations for a variety of things. Worked in the office and in the field and with a lot of contractors. Working with the contractors makes you think, hey, you've got this really great idea. You give it to a contractor and they say, yeah, this is a dumb idea. It's kind of like with a megatree. I could design a perfect megatree that's not going to fall down, but nobody here would be able to build it because either you couldn't afford it or you wouldn't come up with the components. So that's why I'm not going to go too much into how to build a megatree, just the details of what you should be looking for and what are the common points of failure on them. And this presentation is possible because of so many people that have shared things over the course of the last few years, and especially when I put out a feeler for people asking people to share some of their stories, their pictures, and that. So thank you for everybody who shared photos and information. I didn't put any names on any of these slides just to save any embarrassment anybody might have. But also I did have some people that sent me just a list of all of the ones that they found. So I had a lot of trouble keeping track of whose was whose. So thank you for the pictures. If you see yours in there and want to admit to it, go ahead. Some of them you'll know just by the shows, but thanks for everybody that gave me some feedback on here. And in general, I think it's really easy, much time easier to learn from the mistakes that other people make, so you can see what they did, what didn't work on it. Sometimes it's not as easy to say, hey, that one worked perfect, I'm going to modify or do that exactly as the other person did. You see what failed and then you make it better. That's usually what we learn from. We don't learn from our successes, we learn from our failures a lot of times. And there is no one right way to do a megatree or pretty much anything involved in this hobby. There's a lot of different ways to do some. Some things are easier than others, and as I'll point out here, some are more likely to fail than others. But I use the term here more likely because there is no guarantee that something is going to fall if you make it a certain way. There's no guarantee that it's going to stand up if you make it a certain way. There's a lot of factors that go into this with the different loads, the different materials, how you connect all of that. So you'll hear people, you'll see it on Facebook and on the forums and all that. I've done it this way for 5 years. It's stood up to 50, 60 mile per hour winds. I don't have any guy wires on it. I'm never going to add them. That's all fine and good. If you want to do it that way, I'm not here to say you're wrong for doing it that way. I'm saying you're probably at more of a risk for that to fall over than somebody else that has the guy wires properly anchored. But I'm not trying to tell you, hey, you have to do it this way. I'm just giving you some information, and you can do it with it what you will. I would like to point out Walter Monkhouse's xEssentials class from last year. If you haven't seen that, I suggest you go to videos.xlights.org. He does a lot of good information on it. More or less, his was the starting point that I used for putting this together. I'm really not going to go over a lot of the information he gave last time because the video is already out there. I am going to add a few things, emphasize a few things that he may have skipped over. A few things he mentioned in his videos. He's not a huge fan of guy wires. I am a huge fan of guy wires. But that's just a few differences here and there. I think overall he did a great job with that video. And I really like some of what he did with that, calculating the loads and that, trying to simplify it for everyone. First thing I want to talk about is what is a megatree. And I don't think there's anywhere that you can find online of what a standard definition of a megatree is. How tall does it have to be? How many lights does it have? None of that really is that useful for us. And a megatree, well, you know it when you see it. Here's a picture from xLights around the world, and I think all of these would be qualified as megatrees. But we don't have to have this. It doesn't have to be a pixel tree with a face on it. It could just be a bunch of AC lights hanging the same way. Back before the pixels were popular, that's what a lot of people had, and they were megatrees. So a megatree, don't think that it has to be huge. If you want to consider a megatree something 8 feet tall, that's fine. If you want to consider it 40 feet tall, that's fine. There's a lot of things that could be considered that. So you know it when you see it, if it's a megatree or not. So why are we concerned about a megatree falling over? Well, for most of the displays, if you're going through the time and effort to build something like a megatree, you don't want that to fall over because that's probably one of the biggest focal points of your show. You spend a lot of time sequencing or building it, sequencing it, making it look good. Once that falls over, your sequence might not look good anymore. If you've got a big singing face on it, that singing face isn't going to happen. You've got a lot of effects that aren't going to go. It just doesn't look good, and you don't have time to reprogram the sequence to go somewhere else. That leads to things like disappointed viewers, not to mention your wasted time and effort, the cost to repair and replace. And disappointed viewers, that could be your family. That could be, if you have a big show, a lot of people that are coming out for it. You can probably tell based on the guitar whose house this is, and he has a very big show that people come from miles around, and they practically shut down the street for this. If you came out there and this megatree fell over and it was covering up the guitar and the other things, you're going to be disappointed if you go out there. He's going to be disappointed he can't show it to you. Nobody wants that. Everybody wants a show that goes off perfectly. It's bad enough when you have a single bad pixel out that drives most of us nuts. We'll go out there, we'll be spending time and effort to replace that one bad pixel just to make everything look good, especially if it's just a color that's off and making it look bad. Having a whole tree go down, that's probably the worst thing that can happen to you in terms of a show and a presentation. But there's also things that can happen. A megatree falls over, it can damage your property, your other props, your pride, just for making something that did fall over. Here you can see they came down, fell on that guitar prop. Doesn't look like it damaged it too much, but a bigger, heavier tree could easily go right through that. There's houses on both sides that it could come down, break a window, smash some siding. Nobody wants to pay to fix all of that stuff or have that type of damage you have to worry about, especially right around the holiday season when you got a lot of other things. Here's a couple other ones. One of the ones on the left-hand side were up on somebody's roof. That comes down, you could damage your roof, you could damage your gutters, could fall down, break some windows, could fall on somebody, they could get hurt. The one on the right-hand side is our famous pixel pusher that used to give us some musical interludes as he was pushing them on Facebook Live a while back. That one's a very big mega tree, and the top kind of came down on that one. That one was a much bigger one. That one comes down. There's a lot of things on the ground that could be damaged. Even more importantly is if you're a mega tree comes down, you do have the potential to damage other people's property or cause personal injury. This photo here, you see it came down, fell right on the lawn. Not really a big deal if it falls in that way. But you can kind of see in the upper left-hand corner of that photo, the sidewalk's not that far away. If this was a 60, 70 mile per hour wind and this came down, you probably don't have somebody walking down that sidewalk. But if this just happened to fall over because it wasn't assembled properly and it falls down, well then, hey, you could have this fall on somebody. You could have a lawsuit on your hands. Nobody wants to deal with that. And we don't want that to happen. Nobody wants anybody being injured by their Christmas display. You want people to come out, enjoy the show, and not have to worry about things like that. So a lot of it also comes down to risk and how much risk you are willing to take for your mega tree falling down. If you have a show or a tree that's like the upper right-hand slide here, not much around it, looks like it's a relatively short mega tree, you put it up. If it falls over, well, you're kind of disappointed, but there's no harm to anybody. There's nobody that's going to get hurt or injured or anything like that. You don't really need to make as substantial of a mega tree if you don't want to, because if it falls down, well, I'll just put it back up. But if you have something like the other photo there that's right next to a house, well, you really don't want that coming down and damaging your house or damaging a window that it comes down on or something like that. If you are doing a show that's entirely confined to your private yard, you have less risk there because it's only going to damage your property or information. But if you start doing it in a public location or you're really close to your property line and it comes down on somebody else's house, that's a lot more risk that you're taking there to do that. So you want to try to minimize that risk by making a better mega tree. If you were to be doing it in a public setting somewhere, you have even more risk there because you have much less control over who gets near it, how close they get to it, what's going on there. A lot more risk when you're doing that type of stuff. To minimize that risk and design a better mega tree usually is going to end up costing you more money and you're going to have to put more into it. Unfortunately, that risk there is out of your hands when you're going to be getting into public display type things. I don't know how many here are doing public type displays. They seem like they're getting more and more popular all the time. And that's why I kind of gear this towards both the do-it-yourselfer that's just on your own, but also given some of these concepts that are for the people that are doing them in more public locations like that. And I do mention at the end, if you're in a public location, you're going to have certain codes in that you probably are going to need to meet for those. It's not just going to be, well, here's what I think will work. You'll probably need to get permits. Those would need to get approved. And they're going to ask you, well, what wind speed is this good for? You may have to answer that. You might have to prove to them that it's good for a 30 mile per hour wind without falling down. If you do it in your own yard, well, you might just say, well, I think it's good for whatever. And if we get a really strong wind, it falls down. Okay, no big deal. But it's up to you how much risk you want to take with that. I'm not going to try to quantify that by any means. I'm just trying to give you an idea of what's risky, what's not risky when you're doing things. So how do we minimize our risk and avoid failure of our mega tree? Well, it's good to know what the potential loads on your tree are, what the load path is, and the load path is simply how all those loads on your tree get down to the ground or something stable like that. And then along those load paths, what are the weak links? Everything here is just like the chain analogy. A chain is only as strong as its weakest link. It's going to break at the weakest point, and then it's going to move on to the next weakest point. And sometimes that first weakest point is the only one because you can't get load to the rest of it. So in order to have something that's not as risky as others, you have to design and build for all of the above. Now, I'm not expecting anybody here to get out calculations and figure out everything. I'm not going to go through and bore you with a bunch of calculations. As much as I would like to do that, because I enjoy doing things like that, I think that would put everybody to sleep and no one would ever watch this or really get much out of it. So I'm just going to kind of go through the different components that go into a megatree and kind of point out some general information of what they are, what loads are on them, what the weak points are, what you can do to help prevent some of the commonly seen failures that I've seen on them. So a little bit about the loads that I'm going to go through first, just kind of talking some about the different loads that we've got on there. The first thing is what, as an engineer, we call dead loads. And that's just basically the weight of everything. And there's a lot of weight that goes onto a mega tree. The pixels, which for this purpose of the pixels, I'm going to say are all the things that light up, regardless of what type they are, square, round, even if they're the strip type ones. And when I'm talking about the strips, I'm talking about something that you would push pixels through, or the rigidity if you have the strip type LEDs. All of those things have weight to them. You don't really realize it when you're carrying around just one or two at a time, but when you start putting all of those onto your tree, it can add up very, very quickly. Where you really notice is when you get that shipment of pixels from your favorite pixel vendor that shows up at your doorstep and you try to lift it up and you have a little bit of a problem lifting it up because you're not as in good shape as you thought you were. And then you're going to take all that entire box of pixels, probably put it through some type of strip or something with a topper, throw it up on the top of your megatree pole. That's a lot of weight that goes up there that you're trying to support. People forget how much weight that truly is. You also have the weight of your topper that's there. The self-weight of the pole has to get down to the ground. And if you're putting something like a star or other type of fixture up at the top, all of that weight is going through the pole and trying to get down to the ground. Can add up very, very quickly when you think about all the little things. Even if all those little things are only a pound or two, it does add up very quickly. Live loads are things that you yourself are putting onto it. For the most part, we don't have too much on a megatree that I would consider a live load. The biggest thing that we do for a live load on there is you're going up to it and you're pulling on the strips to get them nice and tight so that all of your pixels line up perfectly well. A lot of us are really anal about that. You want them nice. You start pulling on each of those strips and getting them nice and tight. Then you drive stakes down into the ground or secure them to a ring or something like that. All of that weight that you're putting the tension on those strips, that puts additional load into your topper and your pole. You've got to account for that. Again, it might not be much load. It might only be a few pounds, maybe 10, 15 pounds trying to get that nice and tight. That all adds up. That is going through to get through your strip to the topper and back down to the ground. And a lot of people, I think, forget about that. Wind loads. Wind loads are probably the biggest thing that will bring over a mega tree. Winds can go in pretty much any direction, and they can be very, very severe in certain cases. If anybody was on the East Coast this past weekend, we had gusts well above 60 miles per hour, 75 miles per hour in my area. Not something that typically happens. You're probably not going to want to design your megatree to sustain something like that, but if you're in a public place, you may have to. You also, if it's a really big, really expensive tree, may want to do it for something like that. Typically, you're not going to have that many high wind speed things like that over the course of a season, but it really depends on what you want to design for, how worried you are about it falling over and that. The higher the wind speed, the much greater the force is. If you listen to Walter's presentation, he talks a lot about that, how to be able to calculate that. And you'll notice it's not a linear thing. When you only have like a 10 mile per hour wind, it's relatively a low force. 30, it gets much higher. 50, it got, I think it was 10 or 12 times as much. It's not a linear variation. It goes up. And again, you got to account for various directions. I've heard a lot of people say, well, the wind in my area comes from the west all the time. Well, it comes from the west most of the time. But what if it's slightly off? What if it's only 10 or 15 degrees off? you want to make sure that you don't have a guy wire only aligned to pull wind in one certain direction, or a tree that's only going to go in one certain direction. You start getting some of these variations, they can wreak havoc on your mega tree because you thought, oh, the wind's only going to go this way. Snow and ice loads, that's pretty much only a problem for the people in the northern part of the country, but we've had people all around the world that listen to these things. So those are loads that you want to account for. It's extra weight. A lot of times it'll pile up on your topper, cling to your lights, and pull on all of that. The final thing that I have on here is eccentric loads. And what eccentric loads are loads that aren't centered on your pole. And it is very easy to get that. If you don't have a level base and your base foundation is put on a non-level yard, which a lot of people have non-level yards. I don't know anybody that has a perfectly level yard. You can easily get a little bit of out of plumbness of your pole. That out of plumbness basically adds to the amount of bending that you will get in your pole. And you might not even really see it by the naked eye, but if you put a level on there and you're off by a 1/4 inch per foot on there, when you're getting into a 20-foot tall pole, it's up to several inches up at the top. You may not see that, but that amount of force, when you put all that weight on your topper, really puts quite a bit of bending on the pole and can lead to some bad situations. And I'll show a couple of photos of that.
I can look into that.
So the first thing I'm basically just going to go by component and talk about the strips or the different components, what loads they take, what kind of forces are on them, what their typical failures are. So the loads that you would have on your pixels and strips, not everybody uses strips. I think most people do put them through something to keep them aligned, but some people do just hang either pixels, or you could even be doing LED or regular LEDs or in cans on here hanging. The loads that you have is the weight of the strips, the wire that go on there, any connections. That's your dead loads. Like I said, you have a pull on there to make it tight. That adds quite a bit of weight on there to keep those nice and snug. The wind that comes through is going to try to move these side to side, which ends up changing the direction of the load slightly. It's not always down. Sometimes it goes side to side. The snow and ice can cling to that, add extra weight on there. Any of these wires and things like that are only able to take tension. And if you don't know what tension is, pull on something like a string or a rubber band, you put tension into that string or rubber band. If you pull too much, it breaks. Compression is the opposite of tension, where when you try to push something, something happens with it. If you try to push a rope or a string, it pretty much deforms and you can't do anything with it. The pixels and the strips are pretty much the same way. And again, I'm talking about flexible strips like the Buscoyo type things that you punch them through, not rigid strips that you're doing. Those can take some compression. But as you're trying to push on these things, they want to flex all over. They can't really take any of the compression loads on there. They're not holding up your topper. Your topper is holding up all your lights. When you take these and attach them to a base or stake them into the ground, you're pulling on things and putting more tension into that. All of that is going straight up through the strips into your topper and then back down through your pole. I think a lot of people get confused on how that works, and they think, well, I've got this weight at the bottom and it's helping keep everything up. You can't just stand the strip up without that topper. It'll fall down because it can't take that compression in the strip. Another thing to look at is that when you're attaching it, if you have like the trampoline ring and you're zip tying it or doing anything, you could actually notice if you had a few strands that were a bit shorter or your yard isn't level, it's trying to keep that base up off the ground in a certain location because all of those things are taking the tension. The good news is most of the loads that we're putting on here aren't enough to start breaking any of the strips that we're putting on here. A few times the connections at the top or bottom I've seen come loose in a few of the photos. Usually the stakes are popping out of the ground, especially if they're just the cheap little Walmart type metal stakes that are maybe 6 inches long, something like that. But in general, you're not getting too many complete failures of a strip. And even if you do get one strip, your mega tree still works, your pole's not falling over. So I'm not going to focus too much on that. Here's just a photo of one. It's going around. The strips are coming down with the LEDs, tying around the trampoline base. One thing I want to point out over here on the lower right-hand side is you can see where there's a ratchet strap tying this down to the base. It's very important to do. Like I said, all of these strips, when you're pulling them nice and tight, are putting tension that's trying to lift this base up into the air. You don't really realize how much it is unless you don't have something hitting on the ground. If this is heavy, it's putting more tension into these strips, which could break them a little bit more. Like I said, I haven't seen too much of that from what I've seen online here with everybody. But it is easy for this entire thing to get lifted up because you have a lot of tension, or a little bit of tension and a lot of strips that tries to pull it up. If you don't anchor this down, it's easy for wind or just eccentric loading to kind of push this off, blow it over quite easily. So you see one here, you see one in another location tied down. The more you can have this tied down, the better off you're going to be in the long run. Toppers are the next thing. The loads from all of your strips that I just talked about are going to go into your topper before it goes into the pole. In addition to all that load that you're putting on there is a little bit of self-weight on it. You could have snow and ice building up on the top because that's weight. You may connect guy wires to your topper depending on how you assemble it. Some use that, some don't. That puts your topper in bending. What bending is when you're pulling down on one side, pushing up on the other. In this case, everything around the outside perimeter here is trying to pull down on this particular topper. Maybe not all simultaneously, maybe only half of it, but it's trying to push down on one. Your center pole, because you have a brace in here to keep, or some type of bracket of that to keep the topper from falling down, that essentially is pushing up, tries to push up in the center, down at the sides, put this in nice little bending. These toppers, there's a lot of different ways that people have made these, and a lot of them are really good and hold up quite well. Some don't hold up quite so well. Generally speaking, your metal type toppers are going to hold up better than your plastic or wood because metal is better at taking the bending type stresses than the others. Metal also doesn't get as brittle in the cold or is susceptible to UV degradation over time. Keep in mind that the loads, like I said, may not be evenly distributed. If you have a non-level yard and you're pulling a little bit harder on the strips over here than on the strips over here, you're already trying to rack that topper a little bit more than you would be if you had a 360-degree perfectly level yard. Any little offsets that are not even with this, put different forces into here. They can really start to twist and break things. And as you get into that, you'd want a thicker topper or a heavier duty topper like metal as opposed to plastic. Not saying that plastic won't work, but the more load you put on there, the beefier it needs to be. So here's an example of one topper. You can see where the center is pretty much just blown out. The center is what's trying to push up on it, essentially, as everything else on the outside pulls down. It succeeded. Everything around the outside pulled down enough, broke right through the center of the topper there. In this case, you can see it looks to be a 360-degree tree. There's a lot of connections out here. I don't know how tall it was, but there probably was a lot of weight on there, pulling down quite a bit, pops out the center because of that. Part of the problem with a lot of these too is you look at all of these holes that are drilled in here for connecting everything. That creates a lot of weak points. Like I said earlier, your tree is only as strong as the weakest link. The more holes you put in things, the weaker it's going to be, and the more likely you are to going to break around that. If you look around here, it does look like along most of this edge here, it broke right out and separated. This edge here stayed better, but that's just kind of luck. The whole thing's not going to break out at once. Part of it breaks, it falls, and then you don't have the loads on there anymore. Again, I don't know what this material is, where this topper came from, but this is one. Be careful when you're putting a lot of holes like that. If you can order it from somebody, if you're not going to be using those holes and eliminate those holes, do so. The farther apart these holes are spaced, the more material you have, the less likely it is to break. Next one we have here, I tried to blow it up here. I'm not sure how well that'll show up on some screens and that, but this is just an enhanced view of what you have over here. It appears to me it's a wood topper and that it just snapped in half. You can see with the pile of lights that are down there on the ground that this was most likely a 180 mega tree as opposed to a 360, just with the pattern. All the load was on the side. This side over here pulls down on this. The other side's trying to stay up, just snaps that right in half. Keep in mind that a piece of wood, unless it is plywood that is specially engineered to go in different directions, your regular just piece of wood is strong in one direction and weak in another direction and will want to snap in that weak direction very often. I did not have a firsthand look at this. I couldn't tell you if that's what happened here. It looks like a nice flat failure that could have happened there. But there's also, if you look at the blow up here, there's a couple of tie points here where they drilled holes. Again, you drill holes, you make the topper a little bit weak, you put all the load on the side opposite that, and it just snaps right in half. Using a thicker topper here may have saved that. Not using the holes at those locations or putting something in that didn't drill as large of a hole may have helped. Using a metal topper may have helped. Again, there's no way of really knowing, but if you are going to use wood, you can see where this was painted to try to keep some of the moisture out. Wood is going to rot outside eventually unless you get something like a cedar, or if you get something that is marine grade type plywood, that would probably hold up a bit longer. But take a look at that every year before you start setting things up. You don't want to be using the same thing over and over again. If you notice to start warping, rotting, things like that, probably not safe to do. Luckily, though, when you get topper failures, generally what happens is your lights just fall down and end up in a pile down here at the ground. You're really not dropping it down, falling on different people. Not much of a risk. It's disappointing for your show, but it's not really risky in terms of damaging much of anything else. And here's just another example of that. I can't really tell what type of topper this is, but you can see where it fell down partway, stopped. Megatree isn't going to work as a megatree anymore, but there wasn't any damage to the pole itself. There wasn't any damage to anything on the ground. Even the presents there, which look relatively fragile, don't look to have been damaged by this. So a topper failure or a support failure for that topper, which I consider part of it, might not have been in there tight enough, but easy enough to do. Another one here, looks like the topper failed, came down. I don't know if this was caused by the pole leaning or caused the pole leaning. It's tough to tell cause and effect on these, but again, came down at least partway with that. Make sure when you have your topper, there's something holding it up there. Some type of bands in that will work, or screws, but I know people have had screws come loose in that. You want to have something that's going to give you a nice secure thing so it doesn't just slide down the pole too. There's so many different things you can do. I'm not going to go into those, and so many different makers of the pole toppers that do that there's a lot of variety that there's too much to go into on that, and there wasn't enough consistency of where failures were with those to recommend or not recommend any. So again, another one here, looks great, looks pretty on the ground. That's not what they were intending, but the topper failed, came down, made a pile of lights down at the bottom. So now we'll get into the poles. The poles are probably the next biggest location of failure. And it's also just following the load path to the ground. Your loads from the strips go into your topper. The topper sits on your pole, and all of that weight goes down through the pole to get to your foundation or your ground. You also have the wind load that's going to hit the pole. Now, your wind load is going to hit your strips. Your strips are going to pull on your topper, and your topper is going to be up near here somewhere trying to bend the pole in this direction, or somewhere up here it's going to try to bend it all around. But you also have wind that's acting on the pole itself. You might not realize that when you have a 360 tree, thinking, oh, not much wind is going to get there. But wind is going to push on this pole. It's got surface area. It's going to blow on it. It's going to try to tip it over. If you have no guy wires at the top, it's going to try to push the top farther over this way, in addition to the load that's on the strips that are pushing it over. If you have it guy wired, it's going to try to make it into a curved section here, pushing it basically the resultant of it is pushing near the center, trying to buckle it like this. When you have a lot of load at the top and you're pushing out there, it just enhances the ability for failure. The pole takes combined loading. Unlike the other things we were talking about, that like the strips that were just in tension, the pole takes compression, which is the gravity loads pretty much of everything on there, plus your snow and ice and things like that. It also gets bending when you have the wind blowing on it. In this case, I'm showing it at the top. It tries to push the top over this way, bends the entire pole there. Also, there's what we call torsion on that, and that's twisting of the pole. Basically, like when you take it and try to screw something into it, it's kind of hard to show with an arrow, but you're trying to screw it into that. The torsion, for the most part, really isn't a huge load on most of our trees because our toppers are going to spin around a little bit with that. But if you have some type of star or something on the top that you have rigidly attached to the pole, if the wind is blowing on one side more than the other and tries to spin that star in one direction, it may try taking the pole with it too. That could either result in your pole loosening at the bottom, which probably wouldn't spin around that much, or it could try over tightening it. If it tries over tightening it and it can't move that at the bottom, it's going to potentially try to crumple your pole as it goes up along the top of the pole. That really probably isn't going to make your pole fail. Most of our stars are not that big and not able to transfer that much load, but there is some torsion that goes onto these poles that just want you to make you aware of, that there are forces in there that you might not be thinking about. As I said before, eccentric loading very often is a cause of one of these failures. This particular case here, I don't know if the bending of the pole was caused by wind and then it just never came back, or when somebody assembled it, that they put too much load on the left side versus the right side here. But you can clearly see that that pole is leaning towards the one side by quite a bit. What happens once that starts leaning in that direction is all of these strips are pulling on this side. It's trying to bend this pole in this direction. We already start in a case where we've got quite a bit of bending and excess force in the pole that we may not have had otherwise. Now, if you get a wind load that acts on here too, it's going to try to push that even farther. That puts a lot of stress either at the bottom of the pole or onto the foundation, or both, that can lead to failure. You want to avoid this if at all possible. You want to keep this as plumb as it can be. And you want to check this multiple times during the construction of your mega tree. During erection, when you just have the pole up here, put a level on it, put it on in 90-degree differences so you can make sure front to back and side to side is level. Put a level on there, make sure you have it nice when it's just the pole. But then when you start putting your lights up, don't work from one side to the other necessarily. You might want to work from one side and then go to the opposite, work it one way and the other, making sure that guy wires or something are trying to spread out the load. If you go from one side to the other and work around in a circle, one side of your pole is going to start leaning that way just because of all these loads that you're putting on around there. It's really easy to get things out of plumb. After your lights are up on there, check it again. If you have guy wires, you can adjust those guy wires to help keep it straight. The straighter the pole is, the better off you're going to be. This is one of the many reasons that I like guy wires up at the top, because you can make adjustments like that. If you just have this pole and no guy wires, you have nothing at the backside here to try to help pull this back and get it plumb. And right from the get-go, you're already got potential for failure that you're not going to be able to do anything about. This is one particular case. You can see during erection, he was trying to put this pole up. It came crashing down. You can see the ladder kept it from coming all the way down. Most likely this was due to an eccentric load just based on the looks of it. It's possible it was a slightly windy day or something like that, but you can see where that happened. Now, from the looks of it, nobody was on the ladder. They sent this photo in. Nobody said anything about anybody being hurt or anything like that. But you can imagine it'd be really easy to be standing on the ladder, putting those last few touches on this mega tree when that came crashing down. That could seriously injure or kill somebody. Nobody wants anything like that. That's just what we're trying to avoid, what I'm trying to tell you to do with these things. So when you're putting up your pole, use the guy wires. Get it your pole up, put guy wires on it, get it nice and secure, then start putting your lights on it. If you're using one of the poles that you're raising, the Walter Monkhouse poles that you're lifting the center up in that, have your guy wires attached, keep them a little bit taut, raise it up a little bit, loosen them, tighten them as you're going with that. There's no reason you have to go all 8 feet all at once, or 8 to 10 feet or whatever. Do it in stages. That's the best thing you can do. Keep it safe. Have a spotter out there looking at things. If it starts to lean one way or the other, they can tell you to get out of the way. You want to make sure that it's as safe as possible with this. This is just sad all around. You see the failure that happens. You see the potential for somebody getting hurt, and you don't want this to happen to anybody. Poles can fail in a number of different ways. The first thing I'm going to talk about is compression failure. When you put on too much weight onto a pole, it's going to want to buckle. And this is some lab sample things that were done. Basically, the longer the pole, the more they want to buckle close to the mid-height. The mechanism for failure can change quite a bit. It can twist, it can get off-centered in that. But basically, something's going to happen that's going to weaken the pole near the center because it wants to twist, wants to buckle, and that happens. Now, there's a lot of different reasons that you can do that, but generally speaking, you're either putting too much load on that particular thing. We can't do much about that because we don't really have a way to reduce our loads. I want to put up this many string of lights, so we can't do much to say, well, no, I'll only go half as much. We also want to make it a certain height. I want a 20-foot mega tree. If my load says it's going to be too long, yeah, I'm going to go with that anyway. But too much load, too much length, those are common failures. Usually, the ones we can change are not having a sufficient size pole or not enough bracing on it. If we make our poles a little bit bigger, they can take more load. Bigger the pole that you use, the more load you can take. No bracing. The more places you add guy wire to it, the less likely it is to buckle. You can see on these where they're moving around. If you have guy wires on here, keeping this from shifting over to one location or the other, it's not going to be as prone to buckling. Another reason I like guy wires. You can see here, I don't know for sure that this was a compression failure, but this is what a compression failure would look like, one of many different things. Relatively thin pole, probably had a decent amount of load up at top, can easily buckle a pole like that, make it fall down. This can happen too at any location along here. Here it's going right above a joint on a thing. Too much load on here, maybe it's an off-center load with it too, that contributes to it, can easily buckle your pole. Pole sections. There's a lot of discussion that goes on about what you should use and what you shouldn't use for this. It's tough to give any type of recommendation on this because there's so many people that have access to only certain things, or some people have access to a lot more. But in general, for your pole section, the bigger you can make it, the better off you're going to be because it has more capacity to take loads and it has less deflection that's going to happen at the top. As I mentioned earlier, the more deflection, the more offset you have, the worse it off is for you. So the bigger section you can do, the better off you are. However, heavier poles are more difficult to handle to get them into the up position. You're trying to lift this thing off the ground and up, it gets to be quite a bit of work. So you do have to watch that. There is a little bit of offset, and I understand that. A lot of people are using pipe for that, or conduit on here. Just wanted to point out the differences on here between the EMT and especially the rigid conduit on the other side. If you take a look at the outside diameter, there's a fair amount of difference in size. This is all 1/2-inch diameter pipe, but there's a fair amount of difference in the size on that from one to the other, with the rigid being the heaviest, the EMT being the smallest. Inside diameter is relatively close to being the same value. The big difference comes in your wall thickness. Your EMT is the thinnest, your rigid conduit is the thickest. Personally, I like the thickest amount because I want the most capacity and the least deflection that I can get out of it. I know some people have said, well, we don't want to use the rigid conduit because we want things to be flexible. You can use the EMT and have that flexibility in there, but remember, you're going to get a lot of deflection at the top if you don't use guy wires. If you use guy wires, you can more readily get away with EMT than you can if you're not using guy wires. If you're not using guy wires, go for something like the rigid, because you want that to be stiff and have the capacity to get to the base of your pole and sustain everything. As I mentioned, there's a big difference in weight too. The EMT at a 20-foot pole is about 24 pounds. If you go to rigids, it's about 54 pounds. So you're more than doubling the weight when you're getting to these poles, assuming these are all made of the same material, steel in this case. Huge difference there for erection purposes. So that's why some people don't want to go up to that. They don't want to lift that weight up. But again, if you're not going to do that, I suggest using guy wires. I know some people have used fence rail top posts. I put on here the dimensions for that as compared to the 1/2-inch pipe there. You can see this is a lot thinner, especially the wall thickness, only weighs 13 pounds. Very, very light, but has very little capacity. I would never recommend using fence top rail on these. It's just too flimsy unless you're going with a relatively small pole. Maybe 10 foot or less to try doing that. Anything over than that, I think you're just asking for trouble. There's also been some discussion I've seen on the groups over time about what we're using for it. We are generally, and I don't want to say everybody, but most people are using pipe. And pipe is not designed to be a structural member. Pipe is intended to be a pressure application. It's threaded at the ends. You can screw it onto something. It's what Walter has shown on his for being able to go on there. But pipe is used to have something like liquids or gases inside it and not explode. Structural members, which are often called tubes, which can be either round or square, those are designed to have loads put on them and bend and take some of that load much better. You can see over here on the right-hand side, the structural grade here, steel pipe is 35 KSI, but when you get into the HSS sections, which are the tubes, it goes up to 46. Right there, you have more capacity going into those. They're designed to take some of these loads better. They're available in a number of sizes. If you can get your hands on HSS materials, I would recommend that over pipes, but pipes are what you're going to find at your big box stores and that. But you also want to look at the capacity of these. You don't want to just use one thing over the other, just because somebody said, hey, they said I should use this. Well, don't use a round 1/2-inch tube because I said use a round HSS and find that in 1 inch or something like that when you can find a 2-inch pipe. Like I said, bigger is almost always better. There is some discussion about round versus square pipes, and I just want to clear up a little bit of confusion people have, because some people will tell you that square is better. If you have the same dimension that you're trying to put it in, where it's, let's say, 3 inches from this point to this point, and you can either put a square or round in there in that location, your square is going to have more bending capacity, but it's going to weigh a little bit more because you can see out here at the corners, the square has more material in it. So your square capacity, if the wind is blowing in the downward direction here, is going to be about 70% more for a 7% increase in weight. Same thickness, same maximum size, like I said. However, we don't know which way the wind's going to blow. If the wind blows from this location, that 70% extra capacity drops to only 20% more capacity. And then we're still adding the same amount of weight that we added up here because it's the same section. That's really not that much of an increase in capacity. It is an increase in capacity, but you're adding that at the cost of weight. If you were to take the same weight material and of the same thickness, you'd find that a round section is actually bigger than a square section in diameter. Like I said, the bigger you are, the better off you are. And this round section has a 37% more capacity than the weakest direction of the square section. Round is good because we don't know which way the wind is going to blow. We don't know exactly how things are going to shift around when we're doing all of this. Round is, generally speaking, better for things with torsion. So round is what people use for a lot of things, and that's why you'll see lamp posts and your big billboard type signs and things like that made out of round sections. We don't know which way the winds are going to blow and hit things like that. So that's why those are round over square. But both have some benefits. There also are these truss type sections that you can put in here that have all the bracing back and forth. These add even more capacity if you're trying to go up very high. Those can be made from round or square sections that have all these braces going in between them. That is something, if you're going to go this route, you're probably going something very tall, and then you probably want to talk to an engineer yourself about that, not just trying to do it yourself. So which is better when we get into round versus square? Well, that's kind of like 5-volt versus 12-volt. There's no answer that everybody is going to agree to all the time. Round does have a better strength to weight ratio. So if you're worried about weight, you're going to be better off with a round section. You can also get pipe sections only in rounds. They don't make a square pipe section because you can't thread the end of it and screw it into something else. But square is easier to fabricate connections at the bottom. If you want to make an actual structural connection, not screwing it in, then you can go with something like square. But basically, all in all, you're better off going with the biggest section that you can get and be able to find. And choose that on your situation. Get enough size and strength that you want, not necessarily just somebody that tells you this shape is better than that shape. There's really no one shape that is going to be better all the time for that. Don't buy into somebody telling you, well, I made mine square, that's why it didn't fall over. No, you made yours larger. A 6-inch square is going to be better than a 2-inch round any day of the week. But a 6-inch round is going to be better than a 2-inch square. So when you get into bending of your poles that I've been talking about, there's a couple of different ways that can happen. When your pole is trying to bend from wind blowing it, all that wind at the top, a little bit of eccentricity that's trying to tip it over, your maximum load as it's trying to bend at the top comes down at the bottom of your pole here. That is where a lot of people have a threaded type connection, and that threaded connection is the weakest point of your pole. And you can see here's a damaged one. Why is that the weakest connection? Well, the threads aren't put onto these pipes after they're made and they weld more material on. They actually go in and they cut away material to make these threads. So that removes material. Less material equals less strength. When we're talking about pipes, like I was talking about before, structural versus non-structural, pipes are not meant to have threaded connections that are structural and transferring load. They're trying to make a seal at that location. So those threads are tapered, so it only screws in part way. You can see on here the clean threads versus some dirty threads up top. These were probably exposed to the air, had a little bit of stuff going on. These are clean because they probably screwed into the other thing. As we started getting to some bending on that, looks like the threads over on this side compressed a little bit. The threads over on this side expanded a little bit. These took some damage because they were probably somewhere in the middle. You're putting a lot of bending on these threads that weren't meant to take that. It's not a good detail for putting a lot of loads on. So if you have threaded connection at the bottom, I really recommend that you put guy wires at the top to try to minimize some of the load at that screw-in connection at the bottom. Keep in mind too, year after year, as you're threading this in and unthreading it, you may start to get micro cracking in here. You may be damaging the threads. You might realize that it's not going in as far as it used to be able to do. That can happen on either end of the on the pole end or on the base it's going into. You really want to inspect those, make sure that they're well inserted and as many threads as possible are going into it. You can see here, it looks like only half the threads were into it. If all of the threads were in, it would be better, but you can't always do that with these. So there's a couple of different things you can do if you have these type things. If you can put type sleeve or something like that on the inside or outside of it to take some of the loads, if this were to snap, it doesn't move all the way around. That will help you out quite a bit too. Also keep in mind that these type of threads are susceptible to fatigue, which means if you got wind bouncing it back and forth all the time, even a light wind, again, you can start to get some micro cracking in here that eventually tears through, wears it out, and your pole will want to crack there at the base. You'll see if you look at a lot of sign structures, light poles, things like that, if they're round sections, or pretty much any type of section, they'll weld that section to a base plate around the edges here. And then that base plate, they anchor down with a structural type bolt. This one may not be structural, but it's your typical thing that you get at Home Depot that's a smaller diameter. These nuts go up and down all of these threads. They're even, so all of these threads are engaged. And rather than trying to bend one of these and pull on half the threads and push on those, this thread bolt here, the entire thing is in tension. This one here wouldn't have tension or compression, because that would go into the soil. But it's a much better design. If you can find somebody to weld your pole to a base plate and then put your anchors into some type of portable hole, that will generally give you some better results. The problem is then your weld becomes your weak point. That's why I suggest know somebody that knows how to weld to be able to do that for you. If you're just trying to do it yourself and go with that, well, it depends how good of a welder you are. You may have just made it worse instead of better. You can see here, this comes in all different types. These are actually at the same location, just different things. You can see where it cracked off at the bottom. Because it's a nice flat crack like that, no buckling, you can see it's most likely where threads just snapped off. This one was buried in the ground. Who knows how long it was there? I don't know if it rusted or not, but again, probably snapped off right at those rings. Same thing here. This portable hole there, same type of problem right at the base there. A lot of these may have had guy wires on them, and the guy wires fell, and then the load went into the pole, and it breaks it at the bottom. Sometimes one failure can lead to another failure, and it can just keep going and going like that, and it's tough to tell what was cause and effect with that. But clearly, the bottom of the pole looks to be broken in this particular case. That's kind of a blow up where you can see that. I don't think it was unscrewed, but it could easily happen that way. Again, another one, you can see here, the pole is still very straight, relatively speaking. It doesn't look like the base picked up off the thing, so it's most likely the bottom that broke again. A lot of these you can just look at and see, and it's happening to a lot of different people in a lot of different situations. So that's why I'm just trying to share these photos so people can see them, take a look at them, go, oh yeah, what I would do is if I was doing this, I might do this a little bit differently. And again, thanks to everybody that shared these type of things so people can look at them, learn from your mistakes. Another problem is on a lot of these poles, they're two-stage poles, if not more, where you're going up higher and higher, and you have a junction here. Your weak point, your maximum load is at the base, but your weak point may actually be where this transfer takes place. When you're changing sections, the capacity changes. I've kind of tried to illustrate that here. The green line is the demand of how much load you're putting on it. Down here, if let's say you have a 2-inch pipe, your capacity is way out here. Your capacity is always greater than your demand over here. But when you get up here, if you go down to a smaller pipe, let's say 1.5 inches or 1-inch pipe, we drop it down here, you've got a little bit of area here that is greater than your capacity. So you might get a failure there. You can also have it so that neither have sufficient capacity. At this point, we don't really know what's going to break first. We don't know if it's going to break somewhere from here to here or here to here. That's where an engineer can figure that out for you, but as a do-it-yourselfer, you don't know. You just want to try to get it sustained. This is, again, why I recommend guy wires at the top, because that helps reduce this green line. The lower you can get that green line, the better off you are with your blue lines. And you can see here, looks like a junction here, bent right above it with some bending loads that happened. Not sure what the cause of these bending loads were, if it was wind, eccentricity, anything like that, but you can tell the bottom pole is still relatively straight, top pole is bent. You'll see that on the next view here. Same type of thing, bent over mostly at the top, usually where a pole gets a little bit thinner. This one here, this one looks to be probably PVC, but again, you've got a junction here, it goes up, your weakest point failed, comes down. Another pipe is, I don't know if this was the base of the pipe or something, but you're up a couple of, maybe a foot or so by the looks of it, you come up from the bottom of it, breaks over, you didn't have enough capacity there somewhere. As I mentioned a couple of times now, guy wires will help you because instead of having this top being able to move back and forth, the guy wires take the wind load that would be coming on here, transfer it down to the ground. The more you can prevent the horizontal movement at the top, the better off you're going to be. It will take those loads, and instead of putting all that bending into the pole, it puts it in the guy wires. And guy wires take a lot of tension, and that the wire that we use, that you can get at pretty much any big box store, is going to have more than enough capacity for what we want to do. Ideally, in a perfect world, I would say put these up at the top of your mega tree. The higher up you can go, the better off you are because you're preventing more movement from up there. Realistically, though, I know that everybody probably wants to hide these as best they can. So you probably want to put them underneath your topper to hide them a little bit more. You also get the point where, as I mentioned, the wind is hitting this pole here and it's trying to bend it in a half circle type shape. You want to prevent some of that too. And your pure compression on it will try to bend your column in that shape too. So if you can get something at the halfway point, then that will help prevent that. So realistically, somewhere between the halfway point and the 2/3 point is probably the most beneficial to you if you're putting only a single set of guy wires on there. If you're okay with putting more guy wires on and making it look a little bit more like a radio tower, put guy wires closer to the top as you can, and then something near the halfway point. You always want to put your guy wires above your junction point because you're trying to prevent this top pole, which is your weak point, from moving too much. If you put it down here and don't have anything above this, your top pole acts as just as if this were the base and wants to move on its own. So the guy wires really aren't helping you that much. And I'll show you a photo that shows you that in a second here. But above your transitions is always more beneficial and will get you greater benefit. Here you can see that. We've got some guy wires down here. They were below this transition point. It looks like there were some guy wires up top. One of those most likely failed that was into another direction. But the guy wires here helped keep this pole from bending, but everything up above it was still able to bend. It's just like this is the ground at that situation, and all of your weight went through here and just bent that. If these poles were up a little high, or if these straps were up a little higher, it probably would have just pushed that up a little higher. You'd still get bending if another guy wire failed, but you're trying to control where it's happening. The higher up you are, the better off you are. It protects everything below it. Here's another situation where we've got a little bit of a combination of things. We've got the truss-like structure down at the bottom. We've got guy wires coming up to that, and then we got the pole up here. As I was saying, the guy wires only really help you from their location down. This pole acts just as if this were the ground level, and any bending you would have on here would still happen. If I had this situation, I would put guy wires going up somewhere into this point too. It would help you out even more. These guy wires are going to help with the wind loads to keep the whole thing from moving, but they're not going to keep this pole here from buckling. Still good having the guy wires, nice beefy base like that. Good thing, could be a little bit better, but nothing necessarily wrong with it, especially depending on what's going on there. There's no lights, obviously. You might have 10 lights, I don't know. This one, I really like this one as an engineer because we've got guy wires all over the place. It's strapped down. Wind was probably coming, so everything got secured nice up together, keeps it from falling down. This is what makes engineers really excited. Most people probably aren't going to want to go to this much level of effort to do it, but this is a person who, when I was talking about the risk before, they want very little risk. So they have done over and above what is necessarily needed because they want to minimize that risk and be able to open it and close it. Again, it all depends on what you're comfortable with or where your show is and what you have to do for that. I'm going to go a little bit into the foundations on here. The monkhouse portal is probably the most common that I've seen, but a lot of people will just stick it into a cement in the ground and be happy with that, or there's a few others that you'll see. In general, the compression loads that are coming down from your pole and into any type base, it's not a problem there because you're trying to just get it into the earth, and most of the time you're not going to fail your earth for that. The problem is the bending that comes along with that. When you're trying to bend this, something down here has to keep the entire thing from tipping over. Like Walter said, there's the tree root type system that we try to mimic, or that he tried to mimic with this portahole that holds that down to the ground. What he really didn't, in my opinion, emphasize enough, and he did mention it, but I don't think it was emphasized enough to some people, all these little holes that he put in that foundation need to be anchored down to the ground to be able to hold that. The weight of this concrete base alone is not sufficient to keep a mega tree from tipping over by itself. If you have guy wires, yes, it may be fine. If you don't have guy wires, you need to anchor this down to the ground with sufficient anchors. Otherwise, it's just going to tip over for you if you get any substantial winds or off-centered loading. This base, however, is extremely useful for erection. You can take this out there, you can put your pole up into it. It's probably going to hold your pole no problem, just the pole itself. Attach your guy wires to the top if you're using them, and then put your lights on it. If you're not using guy wires, attach your pole, anchor this down. Once it's nice and level, then start putting your lights on. But make sure that you have this anchored, one either at the bottom or with guy wires at the top before you start putting lights on. As the one with the ladder showed, if you don't do that, you could get into trouble. This is one that didn't use the Walter portahole with that. Looks like they just screwed a flange into a piece of plywood that was out here. Trying to get something into plywood, it's just not going to hold up. It's very easy for something like that to fail, especially if it were to rot away at the bottom. The screws pull out very easy. If you had guy wires on this near the top, it probably would have held up better. You might be able to get away with something like this, but just relying on this connection into a piece of plywood, there's not sufficient capacity to do that. I would always recommend going either into the soil with something several feet down or going into some type of concrete base rather than just trying to get away with wood. That's a bigger blow up of it, but it's kind of difficult to see, I'm sure. Another one here, they had a smaller base here that ended up coming out of the ground one way or another. Again, it looks like they had some guy wires here. They probably had a failure of the guy wire and then it tipped. Trying to emphasize how important guy wires can be to something like this. If those fail, your whole tree can come down. Doesn't look like the pole was damaged, but everything's going to have to be lifted back in place, which probably means disassembled to be reassembled on that. So guy wires preventing that wind are very, very important. Another one showing the same thing, same type of thing. This one, you can see where there were some hoops on here. I'm not sure if the guy wires went down to the hoops or not. I can see some of these straps were. But if you're just relying on your straps to hold everything, you got to make sure that this is well anchored to the ground so it can take all that load to keep them from falling over. Another one here. This one did have the hoop around here, and it's got the portahole type base. But if you look at here, I can see these anchors here, but there doesn't look like there was anything anchored into the ground from these points. You really need to make sure that that is anchored. There's not enough weight here to keep this entire thing from blowing over in the wind. If you're going to use a hoop system like this, there's a couple of different styles out there. I said at the beginning, when your straps are all attached to it, you're trying to pull up on that. The weight of this goes up into your pole at that point, and you need to make sure that this is anchored down if you're relying on that to hold your post. I would take a strap, stakes and a strap, tie this down at least at every one of these locations to try to keep this from tipping over in addition to this. The more places you can anchor it, the better off you are. I think a lot of people mentioned that their guy wires fail. Most were because of anchors. I didn't get a lot of pictures of that, but improper anchoring is the main reason I saw for guide wire failure. That's a blow up again, just kind of showing. You can see where there's the holes, but didn't take advantage of staking that down. As I mentioned, you need to tie it down. It's good for initial setup of the pole, but then you want to make sure that these are on here well tied down. Now, if you've been paying a lot of attention, there's two different things we talked about with this, is the pole being the weak link where it can break off at the base with a well tied down anchor, or the pole stays together, but the entire base flips over. you can go back and forth on which one's going to happen first, unless you have a really big pole and a really big foundation. You never know which is really going to fail first with your wind loads and that. So there's a lot of trade-offs with this, and I hear a lot of people say, well, I've got this really big foundation. Maybe they made this thing here, I don't know, 1,000 pounds. They can't move it unless they bring in a forklift. It's tied down. This isn't going to go anywhere, kind of like this one here. Well, then you just break your pole. Your pole becomes the weak length. You could get a really fat pole on here. This one isn't that big, but if this was a 6 or 8 inch pole and it's only into 200 pounds of concrete, your concrete tips over. So it's a little bit of a trade-off back and forth on what's going to be there. Ideally, you don't want either one of them to break, so you make both of them beefy and you're good. Guy wires will help up at the top, eliminating both of these failures, which is why I kind of am pushing for it and repeating that over and over again in here. But you need to pay attention to where you think your weak link is going to be. Is this going to tip over? Is this going to break off? Do something to prevent where you think that weak link is going to be. Tying this down to the ground is going to help you. If you have screwed in here, adding something to the center to it, a sleeve around it, that's going to help prevent that type of failure too. These rings here are being used by people. I think they're being even manufactured and sold in that. This is really great. It's a really big, beefy base. It's got a lot of weight. I would still anchor it down to the ground around the outside, probably at each of the spoke locations. But then realize when you put a pole in here, your pole is likely going to be your weak link as opposed to this base. Base is really good for what you're going to be doing. Keeps the entire thing from tipping over, but then your pole is the weak link. You want to make sure your pole is sufficient for the size that you're going to be doing. This looks like it can hold a very large pole. You probably would be able to go pretty high with this, but just because you have a big hole doesn't mean you're going to fill it with a big pipe. You could easily put a 1/2 inch PVC in here and that's just going to snap over. Well, this wheel doesn't go anywhere. There was a couple of questions, I know, with Walter's presentation on the angles of the guy wires and how important that is. I just kind of want to illustrate that. Typically, people are using 3 guy wire systems. If you use more, 4 wires, 5 wires, 6 wires, the more you have, the better off you are. But most people want to minimize that because it distracts from the show. You'd have 3 wires at 120 degrees from each other like this. If the wind is blowing in this direction here with the green arrow, all the tension is going to go into the one wire here, and that's the resultant force on that. Walter talks about how to figure out the angles in the other direction from the top of the pole down to the ground. But in this case, all of that force is on the one particular wire. But let's say we reverse things and the wind is going in the opposite direction. This wire can't take any compression. The force goes into these 2 wires out here. Because it's nice and symmetric in this case, half of the force is going to go into this wire over here, half of the force goes into this wire. This is where it's tough to show without calculations, but basically this is half your wind. This is based on the angle, and it ends up resulting that this cable still takes the full wind load over here and the full wind load over here, if we are perfectly at 120 degrees. Let's say we're not perfectly at 120 degrees. We cheated it out a little bit because we have a 180 megatree that's all on this side. We don't want some of these lines in front of our audience, or maybe we have something in the way here, and we're starting to cheat a little bit farther and farther. Well, I went through the calculations to show you how quick it gets to be very large numbers. If you're at the 120 degrees, this blue force over here is just 1 times the wind force. That's not a problem. 130 degrees, still 20% increase, probably not that big of a deal. You start getting into 140, 1.5 times, up to 170, 5.7. 180, this number here isn't really realistic. Basically, you get a infinite amount of force because when these 2 are at a straight line, perpendicular to this wind force, they can't resist anything in there. So you start adding a lot of force into these wires if you start cheating on those angles. What's important with that is your anchors for that are really going to have to take that load, and you're going to have cables that'll do that. The cables are usually good at taking that, the anchors not so much. I would also like to point out that wind doesn't need to go in just the side-to-side direction. It comes in at this angle. If it's perpendicular to here, this one can't resist that because it's perpendicular. can't rotate for that. This one goes into compression, can't do anything. The angles end up resulting in this being 15% higher than your wind load here. When Walter was talking about his angles, he was only talking them in the vertical and horizontal, not this angle here. So when you calculate, if you use his formulas to calculate your load, you want to at least multiply it by 1.15 when figuring out the force that's going into a single line and anchor. So just a little bit higher than you may think it is. For your guy wires, always make them a little stronger than you think you need. The wire is relatively cheap and easy to get. If you calculate that you only think you need a 1/16 inch wire, buy an eighth. It's really not that much more money, and it's going to last longer. The wire can easily be overstressed. It can rust. It's going to be out in the elements all the time. If you end up pinching it and getting a little bit of a weak spot, if you have it oversized, you're better off. I would recommend checking it each year before use to make sure it hasn't been damaged anywhere. Pull on it a little bit, bend it, make sure it's not too rusty. If it's rusty, get rid of it, use it for something else, splice onto it, do something with it. There's two failures that I came across with the anchors that seem popular. I did not get any pictures from anybody that had turnbuckles coming loose, but people were telling me that they were coming loose. That's because turnbuckles aren't very good with winds. They want to vibrate, they want to loosen back up. If you just put a turnbuckle on there, apply your tension to it to get everything nice and tight, it's eventually going to loosen up. The things that you can do with that is check it every day, which can be kind of annoying, especially in a windstorm, but use a wire to wrap around the threads to tie the two sides together, put a jam nut in there, even wrapping around something like some duct tape or that so it can't move on the threads will help keep that from loosening up over time. The more you can do to prevent that from loosening, the better off you're going to be. Anchors, by far, though, are the biggest failure. People get those things pulling out of the ground all the time, and that is very difficult to combat because soil types differ all over the place. There is no one anchor that is going to work everywhere. Anchors are not generally being designed by anybody here. We're going with whatever we can find. We're sticking them in the soil. We find something cheap. We twist in this little thing that was probably from a Walmart or other type of big box store, tire cables around it. Use whatever's convenient. It works for a lot of people. It doesn't work for everybody. We also have to factor in that people aren't sampling their soils to see exactly what they have, to see how deep they need to go, what type of anchor is going to grab the soil. Nobody wants to pay for soil tests and do that. I understand that. So go with something that's very big, very beefy. If you can get your hands on it, the deeper you go, the better off you are. Keep in mind that wet soil is usually very weak, and our highest winds usually come with rain or snow or melting or something like that. It's rare that you get high winds and not precipitation. When soil gets wet, it loses its cohesion, especially sandy soil has no cohesion. It's just weight. When you get it wet, it's even worse. Clay will start to lose it as you get there too. So your top 3 or 4 inches of soil really isn't doing anything for you once it becomes saturated. It's easy to pop out. Also keep in mind that if you have disturbed soils, those are also very weak. If you're putting in the anchor in the same place year after year after year, you're loosening up the soil in that location and it may give way. Walter talked a little bit about some spade type anchors that you can get down in the ground, and he said you can leave them there from year to year and reuse them in the same location, or you can use like a post hole digger or a shovel to dig them out. If you dig it out and then put it back in the same location the next year, if you're not going very deep and into that disturbed soil, that soil is just going to pull out much easier than it would if it was undisturbed soil. So the more you disturb your soil, the weaker it's going to be. So try to rotate where you're putting them a little bit, or if possible, leave something in the ground. You can see here, I can't tell you exactly what caused these anchors to pull out, but they both pulled out pretty much the same. They're the screw type anchors that pulled up all the soil that was in there, pulled it straight out, and that led to failure of these type things. Very easy to happen. It could be wet soil. It could just be poor soil. Could be too much load on there, fouling it, disturbed soil. It could even be over tightening of these anchors. If you screw them in too far, and they'll basically strip out just like a regular screw would in wood. We've probably all been there where you've stripped a screw out. It can happen with these too. So when you're putting them in, give them a little tug. Make sure that they're pulling on quite a bit before you're relying on them to hold your trees. Unfortunately, there is no perfect solution for these anchors. Like I said, we're not going to do soil testing. I'm not going to say, oh, you have to use this for every type of thing. I'm just telling you, use as big as you can, use as beefy as you can. But we can also take a lesson here from radio towers, because they use guy wires all the time, and they don't just put a big rebar in the ground or screw something in. They use concrete dead men, is what they're called, because concrete's heavy, it's cheap, and it can resist quite a bit of things. Those guy wires are trying to pull up, so we need something that's heavy to keep that down on the ground. Concrete's a great solution for that. However, we are probably not going to be burying concrete into the ground so that it doesn't move side to side. The weight of our concrete will hold it somewhat, but like I said, the guy wires are trying to pull it up, but then we lack the horizontal resistance as that's trying to get up. So we still need some type of anchor to keep that from sliding. I'll show you something in a second that I think we could use to do that, or in many cases will work for people. If you can embed a concrete into the ground, like a foundation, that would be great. Or you can add anchors to it. And this is just a little something I drew up on here that's based on the bunkhouse porta-hole. Instead of having that center for your pole coming down here, use this for anchoring your guy wires. Put a eye in the center with a washer on it, a couple of nuts to hold that in place, and that's to keep this from pulling out. You put that in the center of your concrete, form up your concrete, take your guy wire, come down, attach it however you would to a regular thing in the base. Now you've got this 150 pounds, 200 pounds of concrete that's trying to resist some of the uplift on there. But in addition, what that gives you is this gives you 8 more locations that you can hook on here, tie this anchor down to the ground to try preventing this entire thing from lifting up. I realize that, yeah, the 8's probably overkill. Maybe you get away with 4. But as opposed to 1 in the ground before, you're adding on the possibility of doing 8 anchors plus the weight of the concrete. This can really help you out, and it's relatively simple and easy to do, especially if you're making one of the other porta holes for the center, do that. In addition, when you have this surface here, you can throw more weight on here as needed to give yourself a little more resistance. Throw some bricks on there, sandbags. I wrote here your old incandescent lights that are just any type of weight that you can put on here if you know a big storm's coming to try to keep this in place. Anything you can do to help resist that will be beneficial to you. Again, it's redundancy. It's all about the more load pass that you have, and eliminating that weak link is going to be better off. You may not need this, but it's just an option I'm throwing out there for people. A few last just general precautions with things. If you're making anything that's going to be substantial in height, and I'll just put that as if it's going to be taller than you are and definitely taller than your house, check your local codes to see if there are any height restrictions. There may be based on building codes or airports or things like that. Check into that before you do that. Your insurance company may even restrict that. If you're going to be in a public location, check and see what the codes are there. Your code enforcement officer will certainly tell you if you're not in compliance, but most likely you're going to have an engineer design that, or at least the engineer approve what you have designed for that. I have never had to look at anything like that for approval, but I'm sure they would be very particular, especially if people can get nearby it. And nearby means anything that's going to be within falling range of it. So if you have a 40-foot tall tree, you need a 40-foot ring around it that's going to have to be secure. Call before you dig, and that includes any driving stakes into the ground, burying any foundations or things like that. Most areas now it's 811, but that's marking out your utilities, because you do not want to put a stake through a gas line, because that's going to cause you a lot of problems with the utilities, a lot of expense, and potentially a explosion. Last thing is, if there are any overhead power lines, general rule is you want to stay at least 10 feet away from them to avoid any arcing. Most of our poles are metal poles. You want to keep away from that, because in a wet, moist environment, you can easily get arcing to thing. Not only could that fry all of your lights, but that could very easily electrocute someone. So that pretty much wraps up what I wanted to talk about. I realize now that I went a little bit longer than I was anticipating, but I hope you guys got something out of it. As you'll see here, I did go through a lot of just general information, and I didn't give any specific designs on how we want to do this. I am an engineer. I could design a megatree that would work, but I'm not comfortable designing a megatree solution for everyone because there's so many variations on this. There's so many locations around the world that are using these things. There's so many different codes. There's so many different ways of building them, what materials you have in that. It's not something that I'm going to say, hey, oh yeah, I can design this and everybody's going to use it, because most people aren't going to build it the way that I would do.
Okay. Well, John, I want to thank you very much for a very thorough presentation, a lot of work, a lot of effort, and a lot of contributions from the community to make this a really great presentation.
The xLights project exists because of people like you. Help continue the project by making a donation today at xlights.org/donate.